Hey there, everybody. Welcome back. This is 14.2, multiple integrals over non-rectangular regions for Calculus 3. Let's just jump right into it. We're looking at examples now. So our first example, we're going to find the volume of the solid that lies under the paraboloid z equals x squared plus y squared and above the region in the xy plane based upon the lines or bound by the lines y equals 2x and y equals x squared. So I drew a picture over here, and y equals 2x is straight line, y equals x squared is here. We're looking at this region right here, and as it goes up to the edge right here, so we're looking like that underneath the paraboloid. We're trying to find that surface. If we set it up where we integrate along dy first, we have 0 to 2 as our outer limit of integration, x squared to 2x. Because we're doing dy, so x squared comes first, then the 2x. We're going in this direction. We're going that way first. So x squared is the lower line, then 2x. We got x squared plus y squared is our paraboloid, the function that we're integrating underneath. Then we're going to do dy dx. We do dy first, x squared y plus 1/3 y cubed. Evaluate at the limits of integration, 2x and x squared. That's all of it written out. And then we clean it up and we get this. And then we finally get that if we really clean it up. Okay. So we integrate this with respect to x. We get that function, negative 1/21 x to the 7th minus 1/5 x to the 5th plus 14/12 x to the 4th. I know that simplifies. I wouldn't leave that way at the end. But now we're doing from x equals 0 to x equals 2. You clean it all up, you get 216 over 35. 35 is only factors are 7 and 5, and neither of them divide into 216 evenly. So that is a simplified fraction. Okay. I know I didn't walk through everything. You can pause this and check the math if you need to. Let's look at the same region if we integrate the other way first, though. We did dy first. Let's integrate along dx first. So, but if we do along x first, we need to rewrite those curves, y equals 2x and y equals x squared, as functions of x. So y equals 2x becomes x equals 1/2 y. Y equals x squared becomes x equals square root of y. I realize that it should be plus or minus, but we are in the positive quadrant, so the answer is positive here. So now, and we can see when we do the limits, it goes from 0 to 4 for y now. So how do we go from here? We integrate with respect to dx first. We got 1/3 x cubed plus x times y squared. Evaluate it at square root of y and 1/2 y. We will get that. We can combine the latter two. So I did it over to the side because I wanted to do this all on one page. When we integrate, we get 2/15 y to the 5/2 plus 2/7 y to the 7/2 minus 13 over 96 y to the 4th. And we're doing y equals 4 and y equals 0. And again, we end up with 216 over 35. So we get the same answer either way. Again, pause the video if you want to check my calculus, my math, and my algebra, really. Peace.